Hello everyone, welcome to Make a Link. Before starting this lecture, I would like to inform you that this lecture is a demo version of our full course. You can access the full course at our website makealink.com with many other features like quizzes after every lecture, e-notes, and discussion forum to discuss the doubt you may have. All the courses are provided at an unbelievable starting price of rupee 1 per day, that is rupee 365 per year. Further, we go by the name Maker Link on Facebook and YouTube, so you can reach us there too for any query. Now let's move on to the lecture. Today we are going to start the 7th lecture in which we will learn about the design of singly reinforced beam using limit state method. Let's take a look what we learned in the previous two lectures. In the first part, we learned some advanced concepts of limit state method related to analysis of singly reinforced beam, and later in second part some examples related to analysis. So if you haven't watched them, just click here. So after analysis, in this lecture we are going to cover design of beam. I have divided this lecture in two parts. In first part, I will explain you about some requirements of flexural designing and the design procedure. With the help of some examples, we will learn to use this concept practically. So let's start with first part. There are a lot of requirements for designing, namely concrete cover to reinforcement, then maximum and minimum area of reinforcement, then spacing of reinforcing bars, and finally the control of deflection. Now let's start with first part, concrete cover. According to IS 456, the nominal cover, also known as clear cover, is a design depth of concrete cover to all steel reinforcement including links. So there might be a question in your mind that why we provide nominal cover to steel. So there are two main factors. The first, to protect steel from corrosion and fire, and second is to give the reinforcement bars sufficient embedment to enable them to stretch without slipping. We know that concrete in hardened state makes bond with reinforced steel. We also provide rug on steel so that steel bond becomes strong. Hence, we provide clear cover to make this bond perfect even after loading. Nominal cover requirement for durability based on exposure condition. Let us recall from first lecture under the topic of durability, I have introduced you to 5 different types of exposure condition. Here, all these are nominal cover according to grade of concrete, and we will be using this grade of concrete according to exposure condition. During construction work, there may be a deviation in nominal cover value. The maximum deviation in nominal cover from the values specified by designers are plus 10 mm and minus 0 mm. Here you can see that we can increase the nominal cover up to 10 mm, but we cannot reduce it. In earlier version of IS code, the clear cover requirements were based on types of structural elements. For example, for beam it was 25 mm, and for slab it was 15 mm, and for column it was 40 mm. But now nominal cover specifications are made applicable for all reinforcement including stirrup and ties in all types of structural elements. We will not use the previous version of nominal cover. Sometimes we have to consider the effect of fire. So nominal cover requirements based on fire resistance are: for 1 hour of fire resistance, the nominal cover for beam and slab it should be 20 mm, and for column you have to provide the nominal cover as 40 mm. So I hope you have understood the concept of nominal cover. Now let us move to the next important design requirement, that is spacing of reinforcing bars. It is necessary to provide the space between reinforcing bars. First, the minimum spacing. We provide minimum spacing between bars to ensure that the concrete can be easily placed and compacted during the casting. On the other hand, we provide the maximum spacing for bars in tension for the purpose of controlling cracks with and improving bond between concrete and reinforced steel. So let me illustrate you some thumb rules of IS code for spacing. Suppose you are designing a singly reinforced beam. This is the cross section of singly reinforced beam and these are the tension reinforcement. This is known as stirrup. We provide stirrup for resisting shear and torsion. We will learn in more detail about stirrup in upcoming lectures. This stirrup is an open stirrup and we have provided hanging bar to hold stirrup, and that's why sometimes we call them stirrup holders. The diameter of stirrup holders should be less than or equal to 10 mm. This is the distance between stirrup and extreme tension fiber, which is known as clear cover. This distance between two consecutive bars called SH, horizontal clear spacing. The value of horizontal clear spacing should not be greater than either the maximum die of bar or maximum aggregate size plus 5 mm. In other words, we will use the value which is lesser of the two. You might be wondering as how to determine the aggregate size. It is the size of aggregate used during the preparation of concrete. Sometimes it may happen that we have to use a lot of reinforcing bars and we cannot arrange them in a single line. We use them in multiple lines. So the vertical distance between these bars is called SV, the vertical clear spacing. The value of SV should not be greater than either maximum bar dia or 15 mm or 2/3 of maximum aggregate size. We will use the least value of these three. One more thing here, as you know, we measure effective depth D from centroid of tension bar, but when we use bar in multiple lines, then effective depth should be measured from centroid of all bars. Now let us move to another beam type, that is doubly reinforced beam. Doubly reinforced beam means that we provide reinforced steel in both tension and compression side. This time the compression bars also work as stirrup holders. We can use bars as a bundle also. This time the horizontal clear spacing is measured between the centroid of bundle. This is another form of stirrup. We call them closed stirrup. If you look at this image, you can clearly see how stirrup look like. Clear cover and effective depth is measured similarly as we use in singly reinforced beam. As you know, we provide maximum spacing to control cracks. For given area of tension reinforcement, it is beneficial to use large number of small diameter bars distributed uniformly in one or more layers rather than small numbers of large diameter bars to have efficient control on cracks. Now moving on to the next topic, maximum and minimum area of reinforcing bars. Minimum area of tension steel is required in flexible member like beam to resist the effect of load and also control the cracking in concrete due to shrinkage and temperature variation. So how do we find out the minimum flexural steel in beam? You are already familiar to this formula in working stress method that AST minimum upon BD should be greater than or equal to 0.85 upon Fy. Here I can convert it into PT limiting. Here PT limiting is the percentage of limiting steel, that is PT limiting upon 100 should be greater than 0.85 upon Fy. On further simplification, the value of PT limiting should be greater than 85 upon Fy. Putting in the value of different grade of steel, the percentage limit will be as follows. It should be greater than 0.34% for Fe250 steel, and it should be greater than 0.205% for Fe415 steel, and it should be greater than 0.17% for Fe500 steel. Now, on the other hand, we also limit the maximum flexural steel reinforcement in beam. The reason for this is that excessive reinforcements lead to congestion of bars, which adversely affect the placement and compaction of concrete. Maximum area of steel reinforcements in tension AST and compression ASC is 4% of gross area. That we call it 0.04 BD. Here B is the width of beam section and D is overall depth. Hence, BD is gross area for beam section.
Sorry guys for the interruption, but as we told you earlier, this is a demo lecture. To see this complete lecture, visit our website. Thank you.